Hi everyone, welcome back. On behalf of the Russell Sage Foundation, the Alfred P. Sloan Foundation, and Princeton University, it's my pleasure to welcome you to the Summer Institutes in Computational Social Science. Today we're going to be talking about survey research in the digital age. So if you all remember from Bit by Bit, I tried to make this contrast between ready-made data in the style of Duchamp and custom-made data in the style of Michelangelo. And so the past 2 days, you all have been learning some about working with ready-made data, screen scraping, APIs, taking data that already exists, and then trying to repurpose it and analyze it. And so now we're going to pivot in the structure of the Summer Institute towards collecting your own data and designing your own experiments and running your own mass collaboration. So you can think of this as kind of a pivot in where we are in the intellectual trajectory of the Institute. So the schedule for today is here. Is here. So we are going to, I'll give a brief introduction to some key themes I see in survey research in the digital age. We'll talk some about sampling, then we'll talk some about interviewing, and then we'll talk some about combining surveys and big data. Then we'll have a break, and then we'll have the introduction to the group activity, which involves you getting a chance to create, deploy, and analyze your own survey, all in about 6 hours. So one of the things about today's lecture is we're going to compress a lot of the lecturing into everything before the coffee break. Then we're going to have the coffee break, then we're going to have the activity. This gives you more time to work on the activity. It gives you less time to do the lectures. And part of the reason I made that decision is when I often give lectures now, people say, oh, that just sounds like what you said in Bit by Bit. Like, why don't you say something different? And the answer is I can't. Like, that is literally, like, I thought as best I could, how do I explain this material? And I did that. And so that's how I think about it. So, so you'll notice that this bears a lot of similarity to Bit by Bit. I've tried to add a few new examples, and obviously we'll have time for questions. But given that Bit by Bit exists, I think we're better off using more of our time for the activity. Okay, so that's a little bit about the schedule. So a little bit about my teaching. So I want to be clear that I'm going to try to have an anti-status quo bias. So I think often in teaching people say, oh, this is what people think, this is what you should do. And I think that is great in many situations for people to teach you the conventional way of thinking about a problem. For the purposes of the Summer Institute, I don't think that's super helpful since you all are advanced graduate students and postdocs and junior faculty. And so what I want to try to do is give you an anti-status quo view of things. So I'm going to say some stuff. Some people might not agree with it. That's okay. The goal is to be stimulating, lead to new kinds of research. I'm going to have an anti-formality bias. So I'm going to say some things that have a technical way of saying them, and I'm not really going to say them in a technical way. I think formality is important. There's a technical appendix in Bit by Bit. There's obviously many, many more books that have these technical elements correct. But here the idea is to communicate some ideas as clearly as possible that will then lead you to this more technical material. And it's going to be quick today. Okay, so one of the questions that I get most often is, why should I care about surveys at all? I particularly get this kind of question from data scientists. They say, surveys are terrible, I hate surveys, people lie in surveys, what answers people give you depends on what question you ask. There's like a huge dislike of surveys from generally people who have to answer them, and also from data scientists who often prefer to work with digital trace data. And so I want to just take a minute to say why I think we should care about surveys at all. And especially in the age of big data, not even in the age of big data. So what I mean is, I think actually surveys will become more important and not less important because of a lot of the weaknesses of digital trace sources. And surveys are a good complement that has some different measurement properties. Surveys definitely have problems. Digital trace data has problems, but they have different problems. And so that creates an opportunity. So why do I think we will always need to ask people questions? So the first is the limitations of these big data sources. This is some of them Chris talked about last time. One way that I like to think about these limitations is there was this, when I was in high school, there was this clothing company called FUBU. So some of you might have heard of this company if you went to high school in the US and you're my age. So FUBU stands for us, by us. And what I think is that most big data sources are nufu nubu. They are not for us and they are not by us. And so let me explain what I mean by that. So as researchers, there's certain kinds of information we often want to collect, and there's a certain way that we often want to store our information. And most of the people creating big data sources in companies and governments aren't doing it for the same purposes that we're doing it. So for example, as a sociologist, I often want to know things about people's race and ethnicity. As someone working at a company, I often probably would want to actively avoid knowing that. Working at a company, I really want to know someone's credit card number. As a social science researcher, I actually don't want to know someone's credit card number because that puts a lot of responsibility on me to manage that information carefully. And so I think there's just fundamental differences in the kinds of things people want to collect and also in the kinds of things people want to store. So let's imagine that you, as a social scientist, if you wanted access to all of Twitter data, you might, for example, want to store exactly when people follow other people so that you could reconstruct the Twitter timeline at any moment and for example, see how it evolves. If you worked at Twitter, you might want to know that, but you probably care much more about an efficient way to store what the network is at this moment, so that you can make your service run correctly. And so often I've seen there's been information that researchers, computational social scientists want to have that people at companies just didn't store because it wasn't their priority. Or they did store it, but it's in some data warehouse somewhere else and not well documented and so on. So for these reasons, among others, I think big data sources are just not for us and not by us. Second is I think there's a very important difference between internal states and external states. So what do I mean by that? External states are behavior. Internal states are things like opinions, knowledge, expectations for the future. These are the kinds of things that social scientists are often interested in studying directly, often outcomes we care about, and they're often predictors or inputs to outcomes that we care about. And it's very hard to infer internal states from external behavior. And so if we care about internal states, those things are not going to show up in big data sources. So for example, if I want to know your attitude about the civil war in Syria, it's not clear the best way for me to learn about that from a bunch of trace data. And perhaps the easiest way and the most accurate way is to ask. And then the third is the inaccessibility of big data sources. So this, I think, is a pretty fundamental problem. Even though all of these things are being recorded, we don't have access, and I think for a lot of things we will never have access. So my favorite example of this is the Utah data center, which is supposedly created by the National Security Agency, and that supposedly has everything in it. It has like every no one knows what's in it, but people think it has like every email, every text message, all web browsing logs, all credit card transactions, everything. That would be an amazing research opportunity, but for our purposes, it doesn't really matter. Our purposes as researchers, it doesn't really matter because we will never get access. And I think lots and lots of data sources are like that. So for these reasons, I think we're always going to want to ask people, but how we're going to ask people is going to change. There's no reason for us to continue to do surveys like people did them in 1950. People in 1950 were working with some constraints. They were doing the best they could given those constraints. We do not face the same set of constraints. We should not continue to do what they did in 1950. Okay, so you can split up survey research broadly into 3 eras. So the first era started around the 1930s, and there was the most common mode of sampling was area probability sampling, where you would pick certain geographic areas and sample areas. And then you would send interviewers to those areas and talk to people face to face. Then in the 70s, there was the widespread diffusion of the telephone in wealthy countries, and people said, hey, we can start calling people on the telephone. And so we switched to random digit dial probability samples and telephone interviews. And this transition was very contentious. If you go back and read the papers about this, they fought about this all the time. They're like, we can't do sampling on the telephone, like we're gonna miss certain people. People aren't gonna respond in the same way over the telephone as in person. And there was bitter fights. But eventually they solved those problems and they figured out how to collect data over the telephone because it was substantially cheaper and faster. And it created a lot of new opportunities. And now, I would argue, we are going through this transition into the third era. Different parts of the research community are different, further along or less further along, I think, in this transition, where we're going to see non-probability samples, computer-administered interviews. And again, we are in this period of contention. People are fighting about whether this is a good thing or a bad thing. And I think, again, we will have to go through this process of figuring out how to take advantage of what is now possible. We can't continue to keep doing just what we've done in the past. There's a third dimension that I think has not been considered in these earlier eras that I think will become increasingly important, which is how surveys relate to the wider data environment. So a lot of times people would do one-off surveys that weren't linked to some big data source or weren't linked to some other set of surveys. And I think as the amount of ready-made data and other kinds of data continues to grow, it becomes increasingly inefficient to run a standalone survey. So I think increasingly we'll start to see surveys much more linked to other kinds of data sources. And this is also about taking advantage of the complementarities. So if you have a large big data source, there's going to be something about it that you don't like, and so you can imagine linking a survey to that. We saw a great example with Jen Pan in her talk, how she did a very simple survey that allowed her to test some of her ideas about which people were 50 Cent Party members. So did you notice that? That was asking questions. It was linked to a big data source. That's like a great example of how a very simple survey can provide a lot of really useful information if it's designed in the right way. All right, so what I'm going to talk about today is this third era. So one way that I think is one idea that I think is very important in thinking about all of these eras and whatever will come in the future is the total survey error framework. I think this is a beautiful idea, and I haven't seen this in a lot of other research communities, where they have this kind of one framework that captures pretty much all the kinds of errors that can happen. And then they work as a community to try to measure and minimize the errors that can happen in this. So the main branches of the framework are in sort of who we ask, and then the second main branch is in how we ask. So these are questions about, on the one hand, who we ask, questions about representation. So these are about sampling, coverage error, non-response error. Second is how we ask, so question wording, question ordering, social desirability bias. So in the same way that I said a lot of arguments about ethics can be reduced to consequentialism or deontology, a lot of arguments about errors in surveys can be reduced to one of these two big buckets. Either you are worried about who you are talking to, or more specifically, who you are not talking to, or you are worried about what those people are telling you. So to give a concrete example, this is President Trump being sworn in. For those of you who are living in the US around that time, you will remember it was very surprising that he was elected. Many of the polls had predicted that he would not win the election. And so after this happened, there was concern about the future of polling and whether polling was broken in some way or whether there were some kind of problems. So there's a group called the APOR, American Association of Public Opinion Researchers. It's a professional organization. They convened a blue ribbon task force to try to investigate what happened in the 2016 election. Not the election. It's not like the Mueller report or anything like that. It's what happened with the polling. Is there some reason the polling was not successful here? And so thinking back to the total survey error framework, I'm guessing you should be expecting it's going to fall into one of those categories, or perhaps both. So let's see what they found. So who we ask and how we ask. So here's what the Blue Ribbon Commission said. National polls were generally correct and accurate by historical standards. So they said, basically, in close elections, even a quite accurate poll could be wrong if you're right around the border. And I believe similar arguments were made about the polling leading up to Brexit. Then they say state-level polls showed a competitive, uncertain contest. So basically, this is saying it was a really hard thing for us to decide. But we clearly messed up in Trump's support in the upper Midwest. Now, here's the part that I think is most relevant to the total survey error framework. There are a number of reasons as to why polls underestimated support for Trump. The explanations for which we found the most evidence are, 1, real change in vote preference during the final week or so of the campaign. So this is actually not a problem with the polls. So the first thing that they list as an association of public opinion researchers is a problem that has nothing to do with them. They're like, we were perfect, people just changed their minds right at the end. So undoubtedly, this happened some. We don't really know how much. Second, adjusting for overrepresentation of college graduates was critical, but many polls did not do it. So here is a question about representation, who we ask. So basically, there are different rates of response when you try to talk to people. And often those response rates vary by demographic group. And so in the US, college graduates were more likely to participate in these surveys, and so the pollsters had to adjust for that fact, and they did not do it sufficiently. And this idea of taking data from a group that's not quite the group that you want and then adjusting it, that's something that you'll get practice with this afternoon. And then finally, some Trump voters who participated in pre-election polls did not reveal themselves as Trump voters until after the election, and they outnumbered late revealing Clinton voters. So now here we have a question about what these people are telling us. It's a measurement problem. So you can see that for the polling related to Trump, you see 3 kinds of explanations. One is actually the quantity of interest changed, which is not related to a problem with surveys. One is about representation, who we ask, and the other is about measurement, what we learn from the people that we talk to. The problems with representation and measurement are ones that researchers have developed techniques to minimize. So there are techniques that you can use to adjust for non-response bias, and there are techniques that you can use to try to get people to answer truthfully to questions, even if they feel uncomfortable revealing that information. So these are not problems that no one has ever thought of before. These are problems where there are at least ideas we can try. Okay. So wrapping up, the total survey error framework helps us organize all of the things that can go wrong. I've mainly talked about the 2 top branches, but within those there are many, many more branches and many, many more things. It's a very useful framework for thinking for yourself and communicating with others. It also can help us think more clearly about why things can go wrong in the digital age. So I often hear people say, oh, people on Twitter are non-representative. It's like, that's a very non-specific concern. And so the total survey error framework can help us be more precise about the specific concerns that we have, which can help us address those concerns and communicate how we've addressed them to others. I'd recommend, if you want to learn more, of this book by Bob Groves et al., which is all organized around the total survey error framework. They have chapters about the different parts. So are there any questions? Yeah? Oh, we got to do the mic.
Hi. So it's a question more related with the results of the report.
Mm-hmm.
Do you remember how they come up with the third conclusion? Because there is also an issue of people over-reporting their vote about who won the election. So how they kind of disentangle this effect?
Yeah. So I don't remember exactly, but my guess is there would be a couple ways they could try to do it. So if you have a question where you think some people are not answering honestly, how would you try to measure that? So one thing you could do is you could look for interviewer effects. So in studies of racial attitudes about race in the US, they often look at the answers people give separately for white and black interviewers, with the idea being that people are more likely to reveal certain kinds of things to a white interviewer than a black interviewer. So it's possible they did stuff like that. It's possible that they looked at the ordering of the questions and tried to see whether, when questions happened in different parts of the instrument, people were more or less likely to report something. Those would be a couple of things that you could try. None of that is perfect. And like you said, doing new data collection after this election is over is also not perfect. So it's pretty hard. Yeah? Oh, let's take the question from the live stream and then Katie.
We have a question from another site. Please correct me if I'm wrong, but a lot of pollsters in the USA are still surveying through mobile like Gallup and Nielsen, right?
Yeah, so this is a question about, I guess, 2 parts. One is about sampling, and one is about the process through which the interview takes place. And so it's true that people are trying to still do telephone surveys. Some people try to do landline surveys. How many of you have a landline phone? Okay, so that illustrates the problem. You don't be embarrassed. It used to be cool to have a landline phone. So I think that illustrates the concern that people have about landline phones. Some people are trying to now sample by calling mobile phone numbers. There are certain, I'm not an expert on mobile phone sampling, but there are certain, one is I believe there are rules against using automatic dialers with mobile phones, so I think it's more expensive. Also, I think there are certain people who want to block themselves from being called. So mobile phone sampling is generally more expensive. Now some people are moving back to address-based sampling, where they send you a letter and then try to include in that letter a link to a website, and then collecting the data through a website. So I would say there's a lot of uncertainty now about the best way to do sampling. And we'll talk a little bit more about sampling in the next section.
So when you report survey results, often you report the margin of error,
Mm-hmm.
but that only deals with a small sliver of the errors that you brought up in total survey error. Do you have any recommendations, or have you seen kind of the best ways to present some of these other forms of error if you kind of know that you have to adjust the data or how measurement error may be involved?
Yep, this is a great question. So the the measurements of uncertainty that we often provide only capture the sampling error and not the non-sampling error. So how do people capture the non-sampling error? So I think there's generally two strategies that I see. One is to try to eliminate the non-sampling error. So I don't think anyone can ever do that. But an example of this would be, let's say you wonder about whether the order of the questions impacts the results. So one thing you could do is you could potentially randomize the order of the questions, and then this would be kind of trying to minimize the amount of non-sampling error. A second thing you could do is some kind of survey experiment or other kind of thing inside of your study to try to measure the amount of non-sampling error. So a good example of this is in studies of interviewer effects. They have different interviewers. They try to compare what you get, information you get from different interviewers as a way of trying to detect how much non-sampling error there is. But really, there's not, the frameworks to do that are not very well developed. So you often see it in kind of either an ad hoc way, people try to use best practices to minimize it, or people do studies that are specifically focused on measuring it. And you very rarely see these studies of measuring non-sampling error mixed into an ordinary, widely deployed survey. Yep, Tom?
What is your opinion of online panels that big survey firms such as Gallup, Zogby, et cetera, maintain? And do you think they're fairly representative, or are they made up of professional poll takers?
We'll talk about that a little bit in the next section, but I will say it's very hard to say in general because they all differ and a lot of it depends on the details, and it's hard to know those details. A lot of the panels are a little bit opaque about how they do what they do, and so if I was trying to choose between a panel, I would be interested in how transparent they are about what they're doing. And if any panel claims to have a secret sauce, then I would probably not be very interested in that panel provider. And we'll talk more about what they're doing a little bit later. Yeah? We'll pass the mic.
Going back to the 2016 election, I think one of the problems for correctly gathering information about Trump's supporters is some of them are in the rural area, and then like if you are trying to reach out to urban areas, it's kind of easy because you can do land survey or phone survey. If you're trying to reach out rural regions, it's kind of harder. And so when you're doing a survey, if you are targeting or hard to catch population, sometimes you do oversampling. But I wonder whether there's a better way, more creative way of doing that.
Okay, so let me try to explain what oversampling is, because some people might not be familiar with it. So sometimes when people are new to sampling, they think the best kind of sample is a simple random sample, where everyone is equally likely to be I know what that was. I really did not time that to be like that, but I fixed. You'll find out later in the day. Okay, where was I? Oh yeah. So simple random sampling. So it turns out that simple random, you can often do better than simple random sampling, where better means lower variance in your estimates. And so one technique that people often use is called oversampling, where if you're particularly interested in certain groups, you collect more people in those groups, and then so then your sample doesn't look like your population, and then you can adjust for that fact by reweighting the data when you make an estimate. So in studies in the US, we often use oversampling if we want to have enough cases in, let's say, each race ethnicity group. So if we do a simple random sample, we won't have very many people in those groups. But if we oversample people in those groups, then we'll have enough to make more accurate estimates about people in those groups. So if the question was something about rural people and whether we could do different kinds of oversampling for rural people, and I think that is definitely a possibility. I think in general, though, it's a good point to remember that if we think about differential access, it's not always based on demographic characteristics. It can be based on lots of other things. So it can be based on where people live. For a lot of online data sources, it's often based on how much access people have to the internet and the broadband and like the connection speed. So my guess is that you would see underrepresentation in a lot of big data sources among people who have limited access or fast access to the internet, which includes a lot of rural people as well. Okay? So let's move on to the next chunk, because a lot of these questions were about sampling, and that's the topic that we are going to discuss next.